All right, how's it going? Oh my lord. My camera. Figured this out. All right, we got it. Hello. Apologies for the ill preparedness, but I kind of genuinely forgot that we stream on Saturdays. I just realized after I finished my breakfast and I was like, "Oh, I'm supposed to be live right now." So here we are. Why am I wearing my headphones? There's nothing playing. Man, habits are hard to get. Habits are hard to get over in a lot of cases. All right. Well, I hope everyone had a great week. Happy weekend. Let's let's keep working on queries. We did a bunch of stuff yesterday, most of which I don't remember. Yeah, we did. We added a bunch of query functionality to register queries, to add new queries, and to keep caching the queries by continuing to update them when new archetypes appear. We need a quick early out if an archetype is empty. We need like a way of checking that. I guess it's simple. You just say like let's just have like an is empty. Let's add that real quick because we need something like that for what we're gonna do next. So we'll just say public bool is empty. Turn. Oh, we have an entity count, huh? Yeah, we do. I thought we only had chunks per list, but we also have an entity count. Cool. Yeah, we'll just do that. We'll just return entity count evaluates to 0. Easy. Turn that into an expression body. So we can just check if the archetype is empty and, pass over it. It's not great, but it saves us some effort. I'm wearing a green shirt right now. I thought it would like interfere with my green screen. It like looks brown. All right. That's reassuring. All right, so let's go through our little query process. So we have this new being called a query. We make a query by passing it its composition. When we create a query, we get a list of archetypes from the game world by registering this query. So registering this query, we add it to this dictionary so we can get it by composition. We go through each component in the query's composition, and we find every archetype that is related to that component type. We check if that archetype contains the query, like fully contains, like has all of the components in the query within itself. It'll probably have more than that, but it needs to have at least that. Then we check to see if our list of archetypes already contains this archetype. Otherwise, if it doesn't, we add it to our queries by archetype dictionary list. Or we add the query to this archetype, right? Because we want archetypes to know what queries they belong to for some reason. I don't totally understand why we have this, but it seems like we probably use this somewhere. We add the archetype to the list of archetypes, then we return the list of archetypes. So the query knows all of the archetypes that correspond to this. So we need to go from this to the actual stream of chunks, the stream of spans, actually, that we're going to need. We can do some of that on the query level, but some of that we're going to need the system to do because the system is the only one that's explicitly aware of the types that are in the query. So let's look at that. So when we create an archetype, we go through this whole new step now where we make a list of queries. We go through each component in this composition of this new archetype. We add this archetype to the list of archetypes by component type. Still tempted to swap component type with component. I didn't like doing that because I wanted to distinguish between the component itself and this object that represents the component's type. But I think it's a little verbose, but whatever, who cares? So we go through each query so we go through all the queries that touch each component. Then we test to see if the archetype contains this query. We check to see if the queries already contains this query for this archetype. We add this archetype to the query if it does not. And then we add this query to the list of queries. And then we assign it for this archetype. Okay, so we know all the archetypes per query, all the queries per archetype, all the archetypes per component, and all the queries per component. So we know all of this stuff. I actually don't know if we know. Well, we do know archetypes by query. Yeah, we know queries by archetype. Yeah, so we know all sorts of stuff. This could arguably be like a list on the archetype itself. I don't know where we use this. We only use this here. So yeah, we'll consider moving this queries by archetype dictionary to the archetype. Just have it as a list. If this is something that you just iterate and not something that you need to search, that makes more sense, but we'll see. I'd rather keep stuff top level until it's obvious who uses it and where. Then we can get more specific once we've handled that part. All right, so how does the query need to help us with this? Okay, we can get rid of this set. I think most of this stuff is going to be handled on the system level. So let's actually start there. So let's go through the system. So we have a move system. The move system is going to get a query that can for all objects that contain positions and directions. And it's just going to move anyone that has a position and direction. It's going to move their position along the direction by delta time. That's just going to be our test case. So when we run, so we want to query this. Let's say private query move query. So maybe we get the query in ready. Maybe we have a ready function. Maybe all systems have a ready function and a run system function. Let's go in the iSystem. Public void ready. Say move query equals game world dot get query. Let's say private const composition is so we need to build compositions. It's the easiest way to build a composition. We could just say something like new composition. Can a composition have can we do this? Can we have the operator overloads like we do here? Can we have these? Or does a composition have an explicit? Well, that's definitely not const. Let's say composition. Composition call out anywhere? No, it just asks for the types. That's fine. The types are all static. So we're making a composition. We just need component type dot flags dot entity ID. What? Is that not on our list? Is entity ID not on our list of flags? Oh, it is. Or it should be. Yeah, entity ID 1. Huh. It's going to be component flags dot in or component flags component type dot flags dot position or component type dot flags dot direction. All this query comp, I guess. So we get our composition for our query. I think if this was any longer, I would do something like this. So we'll say gameworld.getQuery. We'll pass our query comp in. All right, so this is fine. Pretty much. I don't love structuring it like this. Oh, I kind of like that, adding the type flags name. Makes it a little clearer what we're doing here. And make this read only, that is true. So we got our move query and read in ready. We ask the game world to get this query for us. And then during run, we will just say, here's the part where it's like, how do we do this? We need to be able to enumerate over the query. That's interesting. That's an interesting challenge. So to enumerate over the query, we're basically enumerating over some kind of indexing system, but it's a complicated indexing system. This is where structure of array is a little tricky instead of array of structure, because with structure of array, we'll have multiple components in parallel. And we need to be able to iterate over all of those structures in parallel, because we'll need like the position and the direction of a specific, and maybe the entity ID of a specific entity. And to get each of those, we basically need to get the spans for all of them and then iterate through those. So that's kind of an interesting challenge. So, and all we have to go off of is our list of archetypes. But that should be fine. How do we want to do this? So from the archetype, we can get our chunk list. We can get our chunk list of lists. And then there we can get the list, the chunk lists that correspond to our composition. Because the chunk lists is a dictionary based off of flags. Luth Fialdi, 99. Thank you for the follow. Appreciate that. How are you doing this Saturday? On a quiet little weekend stream here. We're working on our entity component system. which is still very, very rough. It's got all the basic functionality, but now we need queries, which is like the bread and butter of it, the thing that actually makes it useful. We need to be able to iterate over our queries here. We almost need to be able to iterate over like a thing, like a concept of like a chunk address. And it's an address that would be valid for multiple chunks. Doing fine. Awesome stream. Thank you. Appreciate that. You're also developing a game? Yeah, hell yeah. What kind of game? Are you also doing it in Godot? I kind of want to add these operators, these public static operators. Add these to composition. I don't know where they go. Maybe under the constructor. The beat 'em up. You're developing it in GDevelop 5. I feel like I've heard of that, but I'm not very familiar. Let's see. GDevelop. Is that like a web framework of some kind? GDevelop 5. Oh, cool. This looks very accessible here. What is this? Full-featured open source game engine. Build and publish games for any mobile, desktop, or web game store. Super fast, easy to learn. Powered by a community making it better every day. How does this work? Oh, you got templates. Oh, this looks very nice. This looks very plug and play. This looks like a great way to get into game dev. Oh yeah, they even got a beat 'em up template. Oh, it costs money. Okay, so they have like a very tightly coupled like asset store system here. It's kind of cool. That's awesome. How do you like this? It's interesting that it has this whole web interface. Did they say it was open source? They did. Oh, that's really cool. You can install it as an app. Cool. For, it's like Construct. Yeah, no, this seems really great. Seems a really great way to get going. Super cool. Well, that's awesome. Yeah, I would love to see progress of the stuff you're working on. We have a Discord. Don't feel pressured, whatever. But kind of hard to share stuff over Twitch. But if you want to, like, I'd love to keep track of, or I'd love to keep, keep an eye on your updates and what you're working on. No pressure though. So what do? We say composition dot. How do we store this? Type flags? Is that what we call this? Type flags. Doesn't this work? Oh, it's because you need way more. This only works for like very bare bones. Okay, so I can't do this sort of thing. Okay, well that was an attempt to make that more lightweight, but obviously I don't understand. This is for like really primitive use cases, I think. This operator system. Oh, you got a trailer. Oh, sick. You check that out. Ondako. That's your YouTube name. Oh, you just posted this like a couple hours ago. This is awesome. Okay, hold on. Let me get my audio set up here. Let's check this out. Let's hit you with the subscribe. Let's get the audio set up on my OBS here. Let's check this out. What? This looks awesome. Bit tubier. That's really cool. Oh man. Oops. No, don't play my videos. We're already doing this. That's really awesome. Yeah, no worries. That looks really great. That's an exciting project. You're pretty good at video editing too, which is not like a easy skill. It's not something I've really gotten into. I'm eventually going to need to. Still trying to get your YouTube verified so you can put links in the description. Oh, is that what you need to do? Hmm. Yeah, that's great. Thanks for sharing. All right, so we need to be able to like iterate over the query. How are we going to do that? So we want it to be like enumerable, but for what? The query to be enumerable over not the archetypes, but like something much more low level. So we need you to be enumerable, enumerable, but for what type? Probably some new struct that we need to come up with that lets us access chunk data. It needs to be able to support an arbitrary number of components. You learned Sony Vegas for in like 5 hours. Oh, okay. All right, how are we gonna do this? So the way this is all stored, we've got chunk lists. So we got archetypes. Archetypes have chunk lists. It has a list for each component type. So it makes sense that we want to be able to get a chunk list. Oh, so chunk lists are enumerable for their own chunks. But the deal is we need to be able to iterate over multiple chunk lists in parallel. We can't just invent a structure here that would support this. We could return arrays of chunks. That's kind of terrible. That's not the worst though. Do I plan to publish on Steam? Yeah, eventually, some number of years from now. We're still really early days on this project. I mean, I see that even though we've been working on it for almost a year, it's been very much about prototyping and like building tools and tech and stuff like that. But yeah, someday. I'm hoping once we get done with this tool set, we can get back into like visual development and get enough like visible stuff that we can like eventually like make a Steam page sooner than later. So I can start posting devlogs and stuff. Excuse me. You said your game, well, your game said free forever. I assume that means you're like, it's just like on itch.io or something. You're just distributing it. Is it mostly like, is it more of a learning project than like a commercial project? All right, so we can iterate over a chunk list and get all of its chunks. How did I implement that? That's easy. Hey, Cyberus. How's it going? It's going to be on, oh, right, because it's GDevelop 5. So it's going to be on some GD thing here. That makes sense. GD.games. Okay, so they have their own game marketplace. You put stuff up there. Okay. I see some fun stuff here. I see some copyright infringing stuff like a Sonic game. This looks fun. This looks like a fun little ecosystem to kind of casually make games. That's cool. You plan to publish your first serious game for free for anyone to play. That's a good way to get eyes. That's a good way to get visibility. But how's it going, Cyberus? How's your weekend going so far? We're working on our query system. We're trying to think about how we're going to present all of an entity's components simultaneously when we're iterating through a query. I mean, it seems reasonable to just send an array of, to just give them an array of chunks. And if a chunk has like 1,000 something entities, it's not that bad to just having to be getting an array of chunks every time. Could honestly reuse the array. Maybe. Can I say like IEnumerable chunk array? Is that not good? Does that not work? I mean, obviously I need to implement the interface. So if we wanted to do this, if we wanted to just return an array of chunks, we would need, you'd need to know You need to know the order of the components. So we need like a little sorted list of components. It seems like the easiest thing to do. The only other thing I could think of would be to pass them an array of chunk lists and to iterate through the chunk lists as we go. That's maybe better because then we only need one array of chunk lists for each query call. We're not like constantly going back and like enumerating through arrays of chunk lists. I don't know. I'm not sure actually. I'm not sure what's better. Because if it's handled by query, then query can at least handle the rest of that stuff under the hood. I guess it'll look pretty similarly either way. And this way, the logic is at least encapsulated in the query instead of needing to be on every single system. You agree on visibility? Yeah. Eventually planning to publish on Play Store? Yeah. Oh, free with ads? Cool. Then for the sequel, if the first game is a success, then you'll do premium things on Steam. Cyberus, game you're working on is a fan game, so also not paid either. Yeah, that's fair. I mean, most games that we're working on, most of these like indie games that we're working on, they're unpaid until they're paid, right? They usually stay unpaid. Cyberus, you're going good. You had lunch with family and played games with friends. That's awesome. Sounds like you've had a pretty full day already. I know it's like noon here, so I should have done more than I have already today. I pretty much just woke up late, made breakfast, and then remembered I had to stream. So we're still getting started here. Luthfialdi, how long did I learn Godot? I've been using Godot for a bit over a year. I've made a few jam games since my switch over. I was in Unity for a long time before that, working in Unity. All right, so if we do this, if we iterate through this, what we're going to essentially do we'd say like for each archetype and archetypes. So for each archetype, we'd get members of their chunk list for. So let's swatch. Yeah, let's keep this as enumerating arrays of chunks. So we have a way of enumerating chunks. We also need an array of getting just the chunk lists that we want. Why did I decide to switch over from Unity? A lot of reasons. They were doing making some questionable business decisions at the time. And also just as a solo developer doing like pixel art 2D stuff, Godot is just better for 2D than Unity or Unreal. Like Godot is just awesome. Like I would never pick another engine for 2D stuff, especially pixel perfect kind of 2D stuff. Maybe Game Maker. I've never used Game Maker, to be fair. All right, we're out of coffee. Things are getting serious. All right, so my concern is that the archetype has like a set of chunk lists. We need the chunk lists that just correspond to our component type. So I guess maybe we build the thing is the move system needs to know what order. I guess maybe its composition determines its order. That's not really how that would work though, is it? Maybe we need to make a construct called like query order or like component order. Maybe we can do that from the component type because we just need to know, given a set of components, what is the order of the components? Like you basically just sort them. I guess the system knows what components it's operating on, so it can just ask for the index and then sort the system by that. Yeah, you're aware of the whole fiasco with Unity. You heard there were massive migration to Godot. Yeah, their user base increased by like 50% or like 100% or something like that. Like last October. Not like, October of this year, but, October 2023. I'm one of those. I'm one of the Unity refugees. And I just never went back because this is just too good. Godot is just too good. Okay, so we iterate through each archetype, and then for each archetype, we need to go through its chunk list. So we can go through our composition. So we'd say something like, for each what? For each variable component in composition. So we go through each component in the composition, in our composition, and we get the chunk list. So variable chunk list is archetype dot chunk lists or component. So we have our chunk list for this specific component. We need to do a yield return around here. So we need to say variable chunks is a new chunk, is a new array. Composition needs to tell us what its size is. We need to know the size of a composition. We have the largest component size. We need like number of components or like component count. Oh, we have component count. Where are we setting this? Oh, we have component count. Sick. We already have that. Look at me. Look at past Dave. Symbol, fun fact, you're also a Unity refugee, but because you wanted to learn something new. I don't know if that captures the feeling of the word refugee. Like the Unity refugees are the people that were forced out of Unity because of these insane decisions that were made. It sounds like you emigrated voluntarily from Unity. But good on you. You were ahead of the curve on that one. How's it going, Symbol? How's your projects going? You got your tower offense. You always have a bunch of projects running. Not me. I'm like one project, one project Pam here. You haven't really worked on it in like a week. That's cool. I feel like it's hard to work. Oh, you're also a one project guy? You just get through those projects so fast. To me, it's like I tune in and you've already got another project going. You just leave projects unfinished. Okay. Yeah. That's like being a monotasker. It's like you're doing a bunch of stuff, but you only do one thing at a time. So everything else that you're doing is just left like wherever it is, like completely out of sight, out of mind. All right, so we make this so we can say composition dot component count. It'd be cool if we could reuse this array. I guess we can, huh? If we just put it at the top. This way we're just at least allocating a single chunk array instead of like one for every archetype. So we also want to store chunk lists then, right? No. So we go through each archetype. They have their chunk list. Well, yeah, we actually, so here we want variable chunk lists. It's a new list, or it's a new chunk list array of composition dot component count. Actually, I guess we can reuse this too, huh? So we just declare a couple of arrays of things. So we declare an array of chunk lists so we can keep track of it in this loop. We declare a list of chunks so that we can keep track of it in the inner loop, which this isn't even the inner loop, I think. Or yeah, it is. So we would say, well, okay, so it's not just enough knowing the component count. We need the component order as well. Right? Formal Goose Foundation. Hello. How's it going? How are you doing this Saturday? Welcome to the channel. All right, so we're iterating through the archetypes, through all the archetypes that match this query. We're going to iterate through each component in this composition. We're going to grab the chunk list for that component. And then once we've grabbed the chunk lists, we can do another loop, and that's the hot loop that we yield return in. So we just go through each chunk list, grab all the chunks. Then once that chunk list is exhausted, we go to the next archetype, do that again. This should be a fairly cheap way to iterate, which is pretty cool. Chunks are passed by value, which isn't like the best. Maybe we can do this with like a ref. Well, it's a chunk array, so it is by ref, huh? Okay. All right. So we go through each component in the archetype. Oh yeah, we need to know the order. We need an ordering. This is where it would be nice if we could just use like a vector, like a C++ like arbitrary length vector for the component identities. Otherwise, we need an ordering system. So we could have because the flags are not ordered really, not unless we iterate through the full list of enum values. So we'd say something like public array. Oh, composition's a struct. We can't do this here. We need to be able to get an order. Maybe we do that from the component type. There's probably some bitwise operation stuff where we could pull an order out of the flag system. Like we could just pull the lowest bit and then the next lowest bit. But that seems iterative in a way that we don't need. I kind of just want an order that we can get. So can we do something here like a static function? Clicking things I didn't mean to click. Public static. Component type. Component order. So that would be, and that would take flags. Or would it take a composition? Maybe it should just take a composition. And it could, we would basically say variable component order is a new component type array, and it's composition dot component count. And then we could say for each component in composition. I don't know if this is how we're going to end up doing this. I'm kind of just trying some stuff out, and we'll kind of look at all of it together and then probably improve it or redo it. So we'd say component order variable component index equals 0. Component index plus plus equals component equals types component. Should we just call this component flag? Whatever, who cares? For each component, types component. So that gives us the actual component type, and it would just be return component order. The index that we're tracking here is almost useless. Although we could, what's our compare to? Oh, our compare to is based on the index. We could just fill an array of these and then sort them, but this is easier and better probably to just do it manually. But they are sortable. The actual component types themselves are sortable. But we don't really need to do that because of how we're iterating. This is fine, right? Because when we iterate through the components in the composition, this is done in order, right? enum.getValues type of component flag. Yeah, the get values should give it to us in order, right? We're on an ad break. I don't have much to do on this ad break, so I guess I'll just hang out. Maybe do a little stretching. All right. This is presuming that we're getting this back in order. I feel like I should test that at some point instead of relying on it as an assumption, but whatever. So we need a component order, and I think only the move system needs to know the component order. So the comp order, the component order, the component order that we get here should let us know what we're working with. If that doesn't work, then we know we've got a problem with the sorting, but let's just presume that we don't. Is this the order is kind of implicit? We're again presuming that we can iterate through the components in a composition the same way here, that we would do so here, wherever, here. Coffee is dead, but I keep going for it, like out of instinct. All right, we're back. We're back from the ads. Hope everyone had a nice ad time. Man, if anyone on the YouTube side notices any audio problems, please let me know, because the YouTube control panel keeps telling me our audio bitrate goes to 0. I should probably just watch some of the VODs and see if we get that. But it keeps complaining that the audio bitrate is 0, and I'm like, I'm pretty sure it's not. Pretty sure you can hear me just fine. But I guess if you can't hear me, you wouldn't know that I'm asking you to tell me that that you can't hear me. But you know, maybe I'll watch this VOD later. This is the second day in a row this has happened. The stream bitrate. Maybe the stream bitrate goes to 0 for like a fraction of a second, and then comes back. I don't know. This seems to be a YouTube specific complaint. All right, so we're going through each of the components in the composition. We're going to instead of using a list, we could always just use a dictionary. And then we don't care about order. But that seems kind of stupid. Oh no, because we're not using lists, we're using arrays. Never mind. Chunk lists array. is what this is. Okay, so each component, we add the component. We add their chunk list to the chunk lists. Maybe the query needs to know the component order as well. Variable comp order. Well, no, this isn't, we don't need to, we can just, this can be up here. Public component type comp order get comp order is component type, component order composition. We use the full word here. Actually, this is maybe a private variable. Or maybe it's not. Maybe it is. So we just say, oh, wait, what is this even what is this even doing for us? This should be a dictionary. Hold on, there's a better way to do this. World, do we have just a dictionary of component types by flag? Oh no, that's what the component type.types is. Oh, so we just go component types, component type.types for this type. What is your index? Well, no, that's not it. That's not sufficient, is it? How do I do this? Cyberus, your fan game is going to load the player's name from the main game save file. You think this will be funny when it freaks people out? Oh, that's pretty cool. That's pretty cool. Huh. So it's not a mod, it's like a separate game, but you're just presuming that they have the main game installed. That's a funny approach. All right, so this component order thing is kind of trash, isn't it? Because we need to find, I mean, we could just do an index of, I guess that's fine. I guess that's okay. I think there's got to be a better way to do this. Maybe we just iterate over the component order or something like that. This has component types. These aren't component type. These aren't flags. Maybe they should be flags. How are we going to iterate over this? Separate game, yeah. If they don't, you'll send them to a name entry screen. Okay, that's pretty cool. That's pretty cool. That'll be a little tricky if it's like multi-platform, but that's a pretty fun thing to do. I think that will definitely mess people up. All right, so we go through each archetype. We need to go through each of their components. And so we have this component. We need to add this to the chunk lists. We need to know where we're adding it. I guess we just go... Well, the composition consists of a flag. So we say, there's a really stupid indirect way we could do this, and it would be really dumb, and I don't think it's the way we should do it. Because the way we could do this is we could just say chunk lists, component type dot types component. It would be component order dot index of we don't do it like this. It's index of, do this like index of array dot index of system array, please. Okay, so we want the index of this component type. That's what tells us the order. And I don't think, so equals, so this would be archetype dot chunk lists component. Oh, you can't really see that last part, but whatever. This is really dumb because we're getting the index of this component type in this array, which is the order of components. I mean, it's not the worst. We should probably, the better thing to do would be to just have a dictionary that we make. We could have a static composition function here. So we could say like, public static component order, public static dictionary component type dot flags int component order composition. So we'd say component order is a new dictionary. And then we'd say for each variable component in composition, we would say component order dot add component. We need to keep track of the indices, so we'd say variable component index equals 0. This is definitely not the way to do this. This really presumes an incredibly stable way of iterating over compositions, which I don't know if that's true. I don't know if that's how the IEnumerable works. I feel like it probably is. It all kind of depends on the order of enum.getValues. Let's read into that a little bit before we trust this too much. Order of enum.getValues. C sharp. Let's see what this person's thinking of. There says there doesn't seem to be a direct way of approaching this. So you're using get values. Oh, but you're trying to order them. Oh, can you specify the ordering? Okay, so I can specify an ordering. That's kind of cool. Are we sure this doesn't just always give us ascending by default? And you just have to specify if you want descending, kind of like a lot of sort calls. It looks like it returns it in an ascending order. This is type.getFields though, I guess. This is enum.getValues. The elements of the array are sorted by the binary values of the enumeration constants. That is by their unsigned magnitude. Beautiful. Okay, so this just... Okay, so I don't need to do anything. I can be pretty confident that I'll get an ascending sort when I call enum.getValues. Okay. That makes this easier. So we add component and we pass in component index plus plus. Hi, can I see the gameplay? Where am I? Hi, where am I? Hold on, let me try to reduce. We've got some compiler errors here. We don't have a lot of gameplay. I'm gonna be super honest. We're working on tools. We've got like an auto tiler tool so that we can build some of our ships in a very basic way. We're still pretty early on. We're working on an entity component system right now for the simulation layer. But how are you doing? How's your weekend going? I can show you some of the tools in a minute. What am I doing? I'm returning component order. Are you using .NET 9? What are we using? I think we're using .NET 8. I get confused because the C# numbers and the .NET numbers don't match up. All right, let's get rid of this last return error here. So let's maybe just hide this for a minute. Hide all this. So we're working on a 2D, but it's a 2D isometric. So here's like the art style in like a little finished piece of of like a room. This is what like a bridge might look like. So we're doing like an isometric 3D. It's 2D art, but it's like, you know, giving the impression of 3D. So we have an auto tiler to help us with this because drawing this is actually quite hard. So we have an auto tiler tool that, presuming I got rid of all of the compiler errors, we can just check out. So we're doing like the 3D chess version of yeah, you think we're at C sharp 12 now. And yeah, I feel like C sharp 12 corresponds to .NET 8. .NET 8 C sharp version. So C sharp 12 is supported on .NET 8 and newer. So yeah, we're on .NET 8, which just feels very bleeding edge. I was doing C sharp stuff in Unity a couple of years ago, and it was not C sharp 12. it was not anywhere close. And I'm really pleased with a lot of the new functions in C sharp. I really enjoy it because I spent a year when I first started learning Godot. I was just using GDScript. So a lot of what I'm about to show you is actually all of what I'm about to show you is powered with GDScript. But we're rewriting the simulation layer. I say rewriting. We're writing the simulation layer in C sharp. So it's kind of parallel to what we were doing. So our idea is like you're going to be, commanding these ships. The art system so far is super simple, but we have an auto tiler, which an isometric auto tiler is like non-trivial. So this is a custom auto tiler I've made that can do floors and walls and doors and stuff. So we can make a room here. This is basically the ceiling. So we can build a room underneath it here. It can tell whether the room is exposed to space. So we have like a flood fill algorithm going around. So we can do the FTL-like compartmentalization stuff and controlling like the flow of oxygen. So we have that and an auto tiler and some visibility tools so that we can actually see where we're mousing over, because otherwise that's kind of a hard thing to do. So we could keep building. You can keep building like 5 or 6 layers worth. So we're going to be doing these like 3D ship designs. I have some new art that I need to integrate into this that we have not done yet, like not curved, but like angled surfaces. So right now everything is just very blocky. We can rotate stuff, which I think is pretty snazzy. So I can put another ceiling here. And now we've made like another room. We can just keep dividing the rooms. We can put doors in, so we can have like a single door here. Put some walls up. Maybe add in some double doors, so the auto tiler can work on doors as well. And the rendering data is separate from the gameplay data, so we can just rotate the whole system. Just kind of disorienting, but so we're gonna end up building some ships soon, hopefully, that don't look like flying housing projects. Once I get some more silhouettes in here, so we can actually start building stuff up. Cool project. You think you've watched my stream before? You remember the project now? I appreciate that. Our progress has kind of been slow since we've decided to start rebuilding everything in C sharp, but I think for the sake of the simulation layer in the long term, it's going to be quite good to have all that stuff. So yeah, we really just have little basic tools that we've been building. And we're spending a lot of time on this entity component system, but I'm hoping it pays for itself in the long run. What are you looking for in the .NET docs a minute ago? Oh, we were just looking. I'm using, so to tell what component types we have that we're operating on, we just have like a bit field. So we have this component type flags bit field, and we iterate over it when we're enumerating the components in a composition. We just enumerate over the bit field. And so I was just trying to make sure that enum.getValues returned a stable sort order, and apparently it does. It seems to return the binary smallest number first, and then gets successively bigger. So as long as we only have unsigned numbers in our bit field, we should be fine. That's what I was looking for. But yeah, I love some of the new C sharp stuff is so subtle but just so nice. Like when I remake like if I reassign a variable and I want to reuse some of the fields of the variable, I can just say, I'm trying to find an example. I can just say like I want this struct with this value. And so I can change one or more of like the struct's value when I reassign it, because we're trying to have like, immutable structs. So it's really cool that when you recreate it, you can like pick and choose what you want from the previous version of the struct. It's kind of cool. There's a bunch of cool little stuff here. I can't even think of it all, but as I've been learning, relearning the modern C sharp over the last month, it's been like really great. CCPRN says 2025 will be the year where C sharp is finally F sharp. Maybe. I really have no expectations for 2025. Could really go any direction. Hello, happy weekend. Yeah, hey CCPRN. Welcome to the channel. Appreciate you hanging out with us on a Saturday here. I know this is kind of our slowest stream of the week, but I'm honestly okay with that because, like, I didn't work today. I almost forgot that we were streaming, so we're kind of just chilling. We're working on our query system, our entity query system for our little entity component system here. So we're working on our query. So let's get back to that. So how are you doing? Have I used span for performance? Yes. Where am I? We are using span. We are using span like nothing here. And I will walk you through kind of the fun ways we've got span going. So, we've got our components, and we've got our an archetype might have any number of components. You're doing ECS with Godot, C sharp and Godot. Yeah, I'm enjoying adding this. It's kind of like a sidecar to my Godot stuff. So the Godot is going to be the one handling like rendering, UI, all of that stuff, and then we're going to have the simulation layer in our ECS, so that we have our rendering and game data separate. So we're going to have this whole separate world of ECS in C sharp here, and then we'll sync it back with the Godot scene tree as we need it. What is my title at work? I'm like a kind of HR administrator. Where am I? I do back end stuff. I do a lot of stuff around like audits and reports and onboarding, offboarding, lots of paperwork, like a lot of automations around people systems, like people operation stuff. That's my day job. Played around a little with Bevy in your youth. Now you're just doing Godot with GDScript. I love Godot with GDScript. Most of what I've written so far for this game is in GDScript, and all of the rendering and UI stuff, anything that's in the scene tree is probably going to continue to be GDScript because I kind of like it. And then we have a clean break basically between the Godot side and the C sharp side, or in the the rendering and the gameplay side. But yeah, let's talk about span. So we've got archetypes. Archetypes have compositions, which is a list of components. The archetype doesn't know it does know what components it has. How's AI affecting us? Not much yet. I don't really do a lot of the recruiting or other stuff, which is like kind of in the HR world where AI has started to take hold. I do a lot of automations, but my automations are procedural. They're like designed by hand, because it's got to be precise. We can't just have a statistically believable answer to things. We have to have like the actual answer to stuff. So far hasn't affected me. We'll wait and see. But yeah, so here's where span comes into play. Where am I? Our archetype has a composition. We have all of these abstract. We can't operate on the exact type of the components because we don't know what they are. So we're using like generics. And so our storage system is chunk based. So each archetype has a chunk list for each of its components. And then, each of the chunk lists have their list of chunks, what they're named for, what they're famously named for. And the list of chunks are just generic chunks. Like, we don't know what type the chunks are because we have, the archetype just has a list of, or has an array of chunk lists. So we don't know what type we are. So we go down into the chunk. So the chunk is super lightweight. It's just a 16 kilobyte memory buffer, just in byte form. So whenever we need a new chunk, we just allocate 16 KB of bytes. We just keep track of what the item count is. The chunk list knows how many items we can fit in a chunk. And then whenever we need one of these and we actually need to use it, we go to this kind of helper component or helper class, which is the component type class. And this provides us a way to get the actual types of our components out. And this is where we use spans. So we basically say oh, you want to read a chunk. You just pass in the type of component that you expect this chunk to be. So you say component type, like entity ID, position, direction, whatever. And then you just get a read-only span of it, or you get a read-write span of it. And you just pass in the chunk that you want to read or write. And we just get it. And we just operate directly on the memory. And we just recast it to the component that we think it is. So it's really great because we can a lot of times we can operate on these chunks without knowing what they are at all. They're just bytes. But if we actually need to do something with them, like we need to write or read from them, we can just use span. I love span. Span is great. And it's really flexible because right now the memory underpinning the span is managed because I just don't care. And it's not an issue yet, but span is flexible and memory is flexible. So if we need to at some point, we can switch over to an unmanaged memory model, and the rest of the system won't care. We'll just need to manage the memory a little more carefully. We're already doing it a bit just in case, just to. I will lose the benefit of an ECS if I use list, because the efficiency of ECS is to utilize CPU cache better in threads. Yeah, but when we're iterating over chunks, like when we're actually iterating over the entities, we're doing so with a span. And each chunk has hundreds, our components are small, so each chunk holds 1,000 components. So you go through 1,000 components at a time through a span, and then you got to hit a list or an array to get the next chunk. But you do that once every 1,000 times. So we are still utilizing the cache because a whole chunk just fits in the cache. And then there's a little bit of a loss when you gotta get the next chunk, but we can probably improve that over time. That's the system that we're working on right now. Threads is a bit of an issue. You're right. We aren't set up to handle threads yet. But I don't really care too much about that. If it becomes a problem, we'll just move the whole ECS onto its own thread. And that'll be easier than trying to make queries and systems thread safe or whatever. We just move the whole system over off of the main thread to its own thread. But yeah, you're right. We're not getting every single performance advantage of an ECS, but part of that is we're using C#. We're not we could be writing this in C++ if I was a better programmer. We could actually be doing this in such a way where it's bleeding edge. But we're going to see. I'm trying really hard not to prematurely optimize this system because this isn't I don't think this is going to be an entity component system where we have millions of entities. This is going to be an entity component system where we have tens of thousands of entities, which might not even stress the system at all. So I want to wait and see. But you're right. These are things that we need to consider and keep an eye on for sure. What kind of stuff do you work on? Or am I? And CCPRN if you're still here. I always like hearing about people's projects. C# async or thread pool is just fine. Yeah, exactly. I don't think we need to go too crazy with it yet. We need to be a little careful because there is a point. There are 2 points, at the beginning and the end where we reach back out to Godot to, synchronize back with the scene tree. So we just need to make sure we can, manage those sync points well enough, but that should be easy. We only do that, once, maybe twice, depending on how we want to do it. How much of latency we want to have on input, basically. We could do it all at once. That would be easy. Or we could do it twice if we want to pull the input early so that we don't have our inputs not too many frames behind. But who cares? It's input. I don't know. We'll see. We'll get there. We'll get there when we get there. This is definitely my first time making an ECS. I've used a lot of ECS. But this is my first time building my own, so I've definitely got some lessons to learn. All right, so we've got our chunk lists. So right now we're working on an enumerator for our query. So a system will just have, right now a system's gonna have one query, but obviously we'll have more than one query eventually. So we need a way to iterate through the query and grab all of the entities, or iterate through the entities in the query. It's kind of what we're working on right now. And our test system is just a move system that's just going to grab all of the entities with positions and directions and then just increment the position by direction. You love testing performance and use OpenCL or FPGA. My problem is I don't know if I love testing performance, but I definitely think about it too much up front. Premature optimization is definitely a thing I struggle with, where I'm like, maybe I think this is going to be a problem, so I think we need to design this really complicated workaround for this problem. And then I get around to the performance testing of it, and it's not a problem at all, and I'm like, oh, damn it. And I don't know how much of a problem it would have been because I designed around it too far in advance. So I don't know. I'm scared. I'm trying to be more careful not to do that too much. We set up a caching system for our query. And it was do we need that? Do we actually even need to cache the queries? And it's I did it because it's instinct, because that's just what you do. You cache your queries, unless you need to not, unless you need if you have a very specific purpose and you're worried about, structural changes, which we aren't, because again, this isn't multi-threaded. So we're not worried about it yet. And we may never be. Honestly, part of the reason I picked ECS was because I like it from a design standpoint. It avoids kind of what I've had someone refer to me as the web of references that you get if we tried to do this whole thing with bespoke objects and instead of entity component systems, if everything was just its own bespoke object. It gets so messy. And so I almost just prefer ECS from a design standpoint. And then it's great if we get the performance benefits, but yeah, you find getting the product first to market is more important. Definitely way more important. But yeah, I think if we use an ECS, the nice thing about the ECS is that it's optimizable. It might not, our first version of it's not going to be optimized, but it'll be easier to optimize an ECS than it would be to optimize this pile of bespoke classes and objects that we use to represent every different type of gameplay object. That'd be harder to untangle later, whereas an ECS should be relatively easy to optimize if we need to. Now, as to why I'm doing this in C#, there's no good answer. I will just throw my hands up and say this is just what I'm comfortable with. It's definitely not the language best suited to doing this. All right, so let's get back. Let's kind of get back on track here. What are we doing? So we've got our chunk lists. We're grabbing our chunk list. We're grabbing each chunk list from our component using our, okay, so we're not using this horrible, nasty thing here. We made a new structure for this. So this is going to be composition, or wait, component order is going to be a dictionary. Maybe this should be called component index. I don't know. I don't know. We'll stick with component order for now. Component order. So it's a component type dot flags and an int. So it's an index. We'll change this name. This name is terrible. So component order is actually composition dot component order. Composition. It'd be cool if I could call a composition and just be like, give me a component index in this order or in this composition. But I don't, doing that in a static way would be a bit of work and we'd be doing it all the time. So it's probably easier to just cache the component order directly. And then so here we say component order component. Way easier. We're just getting the index of the component in the composition. Be read only. All right, so we get our chunk list. So each of these components, we get our chunk list here. And we do that once for each archetype. And then once we have our chunk list, now we can go through how do we say this then? What do we say? We say something like, do we need to keep track of the chunk index and do like a for loop or like a while loop or something? Variable chunk index equals 0. Actually, we don't need to do that here. We can do that here. Oh, we can just say for variable index for variable I equals 0. I is less than archetype dot chunk lists dot count I plus plus. So for each chunk in the chunk list, we say chunks component order. Or hold on. We need to say for each chunk list. This is kind of gross and we'll probably make this better, but I just want to see the logic here. For each chunk and chunk lists, or for each chunk list and chunk lists. So for each chunk, we go through each chunk list. We say chunks, component order. No, we can say chunks. No, we need the index. I'm gonna say for variable II. We go for, so for each chunk we go for, and then for each component. I wonder how many of these compositional helper properties should be here. I guess fine. It's 3 integers so far. It's not bad. But we could just make these. We don't have to actually store these. We could just calculate these whenever someone wanted them, but whatever. We'll see how often they're being called. Chunks, component order. Oh, chunks, II. Equals chunk lists, I. Is this it? Why does this not work? Oh, dot chunks, II. No, this isn't right. Chunk lists, II. What do I have this I outer index for? So for each archetype dot chunk list dot count. So for each component, no, this isn't right. This isn't right. It's not this. We go for, we say for each chunk lists dot length. So we're going for each component in the chunk list, for each chunk list in the chunk list. So we get all the chunk lists. Now we're going through each chunk list. Why don't I just say for chunk list and chunk lists? Oh, because we're using the I. So it's chunks I is chunk list I. What the fuck is this part for? Getting a little too nested. I'm getting a little nested in my head here. Having some problems. So we go through each component. We add the chunk list that corresponds to that component from the archetype. That gets us a reference to the chunk list. And then what we're doing, and now we need to build this chunks array, which is just the chunk that we're iterating on for each of these chunk lists. So we need to go through each of these. We go through each of these, so that's why we have this I. So we go through each chunk list, and then we add to this chunks thing. Oh, I have this in the wrong order. So it's actually for I is less than. I have these flipped around. That's what's happening. Oh, and it's not for component count. It's for archetype dot chunk lists dot count. No, it's. I need a chunk list on here. I have the chunks per list here. This maybe needs to be a. I guess we could just say chunk list. No, it's not chunk list. So instead of this chunks per list thing, this needs to be a property because we actually need to be able to read this. Let's make this into a public property. Because we need to know this number. Why do I set this to 0? It should just be 0. I think it's because I was setting it to 1 at some point. But we can just give it its default initial value. All right, so now we have a chunks per list property. So we can just ask the archetype how many chunks per list you've got. So as long as this number is less than chunks per list. All right, so here's the outer loop. For every chunk, we iterate through each component and we assign. So we need this II. Let's maybe rename these to be more helpful and descriptive. So this one is chunk index. And then this one is component index. So for the component index within this chunk, we get chunk lists, component index again, and then we do chunks, chunk index. All right, here we go. That's it. So we just grab whatever chunk we're on. So we iterate through all the chunks, and we grab the chunks for each index, put them in here, and then once we've done that, or no, between the two, so after this, so right here, this is where we yield return chunks. So this will give them an array of one chunk for each component. And then we can go through that chunk for each component. And then when we're done with that, we get through the next chunk and the next chunk, and the next chunk. And that's how you iterate. And then once we're done with all of the chunks for a given archetype, we move on to the next archetype. Okay, that's not too bad. That's not too bad. I thought that was going to be worse. I thought that was going to be a little clunkier than it's turned out to be. I mean, it's not great, don't get me wrong, but it's better than I thought it was going to be. Oh, man. Red alert. We got a raid coming. Practical NPC raid here. Happy Saturday. Happy Saturday, Practical and Raiders. How's it going? All right, we can stand down red alert now.
Maximum warp.
Maximum warp. Yes, indeed. Colchis, welcome in. Thank you for the hydrate. Oh, and the stretch. Colchis, hello. It's Camilos. Thank you for the hydrate and the stretch. P. Gorley, how's it going? How's the stream, Practical? How's the game coming along? Reasonable. We're working on our entity component system. We're almost done with it. Oh, thank you for the follow, Camilos. Stream was pretty good. I heard you'd forgotten how to stream. So how was that? How's that? Getting back into that. K-Tronics, thank you for the follow. Here's what we're working on, everybody. We're working on like isometric 3D version of like FTL, faster than light. So this is kind of a little piece of concept art I knocked up for it. Really low res, really pixel art heavy. We're doing everything ourselves here. It's a solo project. We're still deep in the tools stuff. And but yeah, we got some tools I can show. So we're working on an ND component system right now. We can ignore that, but we got most of the functionality. We're working on the query system right now, which is a way of, iterating through all of the entities, depending on what components you want to iterate over. But over here in the Godot land, is that the art of the game? Yeah, it's kind of the only real piece of the art of the game. I've been working on some other art that I want to integrate. Like I'm trying to think about things like animations for my little guys, but I'm really bad at this. Like I've never done pixel art before. So here's like maybe like a little fisticuffs animation that I'm knocking up. We've got like maybe like a simple like run animation. These guys are going to be small on the screen. They'll be like this big or something. So I'm trying not to go too crazy with it, but it's an interesting challenge. For environmental stuff, we've been working on the hull pieces we're going to use. So like angled hull pieces that we can draw in here for our auto tiler to eat, to consume, and draw. I can kind of show our auto tiler off here. You're digging it? Thank you. I appreciate that. It's a real struggle because I'm doing it all myself. Oh, this is not the right scene. I just launched the wrong scene, everybody. Well, at least we know we don't have any compiler errors. It's actually a really good animation. I really appreciate that, Kulkas. I think the scale really helps me. Like the really low animation scale helps me because it's really obvious if I've made a mistake. Like the fact that the little dudes are like 14 pixels tall and like 7 or 8 pixels wide. It's like really obvious if I've made a mistake. But here's our auto tiler, which uses little pieces, little individual faces. You can kind of see with the outlining that the auto tiler is pretty clever. It can actually read more than just floors, so it can read an arbitrary number of layers. So this is the one that builds the floor, but we can go down here and we can start adding walls. I mean, I guess that's the ceiling now for this room. We also have a flood fill algorithm, so you can see the color change, so we can acknowledge whether a room is sealed against the vacuum or if it's exposed to outer space here. So we can do that FTL kind of stuff. So we can kind of do these kinds of things. We got ads starting in a minute, so I'll try to demo this really quickly for anyone who wants to dip. We can throw in some doors. We can auto tile our doors as well. And we can just keep building layers. So it's really simple right now. It just has a block system. But this is our custom auto tiler for this stuff. So eventually we're going to be able to build these 3D ships and have people run around them and, man battle stations and do whatever it is that little Star Trek crews do. Thank you. I really appreciate that, you guys. I haven't been able to work on this stuff for a while because we've been really deep in the systems design for the gameplay layer, which, like I said, is an entity component system. We can rotate everything too, which is kind of the best part about having it be separate, where what we're rendering is just a view into the game data. That's kind of the stuff we've been working on. But yeah, really appreciate the raid practical. Hopefully you got a nice weekend ahead of you here. You really want to make an isometric game one day? It was way harder than I thought. So when we were looking at doing like the art, when we were looking at doing the art for it, I had to realize that like for the auto tiler, even just with just an interior, middle, and exterior holes, we had like this insanity. So we had all these different types of hulls, and then for each hull type, oh, we're in ads. Well, anyone who dodged the ads, this is the insanity that we've had to tackle with to get this auto tiler to work. These are all the different combinatorics of each outline combination. So we'll just kind of hang out here for a minute while we're going through ads. We ended up swapping to a different system for modeling this because this is combinatorically insane, but this is the complexity that we were dealing with an isometric auto tiler that has an outlining system. I kind of want to turn this into a poster dedicated to my insanity. Did not dodge a thing. That's all that. Yeah, it's nuts. It's nuts. Finish Memori and then you can do it. Yeah, do it. The logic is definitely more complicated, obviously, but being able to fake 3D with 2D is just fun. That's just a fun thing to do. And then what we're kind of doing right now is like, I kind of want to structure the game world or the game system so that we have like this kind of basic scene tree where we have our root game node and we have like a node 2D that's like the game board. So everything that you can see and interact with is on here. And then obviously UI. And then the game system will be a node that we implement in C# land here. And this is going to be our hook into the scene tree. So from this hook, we've got our whole ECS world over here, which is where all our game data is, like all of our entities and stuff. And the game node has a main system, which it runs and passes in the delta time. And then the main system does like literally everything else. It manages running subservient systems, all of that stuff, updating all the. So we have all our game data in this world. And then we just, if we need it to come back and like put something on the game board because like this ship has come on screen or something, then we just throw the stuff that we need into the scene tree. So for me, I'm kind of using the Godot scene tree just for stuff that needs to be rendered or interacted with, and then everything else is going to be simulated entirely in C# land without any kind of nodes or other like kind of more heavyweight things. Dealing with it. So yeah, I'm kind of pleased. We spent like a month on this entity component system. We're getting pretty close though. We're just working on queries. We can already like create entities, add components, remove components, delete entities, reuse them, like recycle them. We can do all of that basic stuff. But now we're developing a query system so that like the systems can actually use them. So we could have a move system here that grabs every entity that has a position and a direction and just moves each entity's position by its direction or along its direction by like, I don't know, delta time or speed. We could add a speed component if they have a speed, but for the testing purposes, we're just doing this. But yeah, thank you all for coming in. Thanks again for the follows. Camilos, Ktronics, Colchis, all the Ks, all the K letters represent. And yeah, let's see. So I just finished this chunk enumerator. So we should be able to get our chunk lists and just all of our chunks for each entity. So we're going to get an array back that is whichever chunk as we iterate through all of them. We'll get an array that has like one chunk for entity IDs, one chunk for positions, one chunk for directions. In this case, it'll be basically an array of chunks, one chunk per component. And then we'll just iterate through all of these. We'll keep reusing. Ideally, we'll keep reusing this same chunk array. I'm hoping that's how this will work. And we'll just keep cycling through it, substituting in the next set of chunks. And this should be a really easy way for the system to iterate over all entities. So we need to plug that in next. Chunking it up in here. I know, I'm so sick of saying the word chunk. As soon as we're done with queries, we're never going to think about chunks ever again. They'll exist and we'll just ignore them. Because that's what, this week we were dealing with so many bugs, so many chunk bugs, so many bugs at the boundaries of different chunks. Because like a chunk can only hold so many entities. So if we got more than that, then you need to add a chunk or you need to remove a chunk and you need to copy stuff over all the time because we use an archetype system. So if an entity adds a component, if an entity only had a position but now has a direction, then you got to take it out of the old archetype, put it into a new archetype. Like there's so much entity movement happening that is so tedious, but it works. We did it. It works. We tested it this week. All we need to do is get the query system working, and then we have a fully functional entity component system that can only do the bare bones, but that's all we need right now is bare bones. So yeah, let's plug this into the system here. Let's try to use this query system, or let's try to use a query that we make in our move system and see if we can actually move these entities around. So in a run, we would basically say for each variable chunks, for each set of chunks in query, in move query, so for each array of chunks in move query, we'll just go through. We have our component order. Oh, but it's not. This has been changed. The structure of this is different now. So component order is actually component type dot flags. It's a component type flag, and then an int. This isn't a Godot dictionary. It should be just a systems dictionary. We get this by saying composition dot component order for query comp. We could actually do this up here. We actually don't need to do this in the ready function. But who cares? We'll do it here for now. And then so we're going to go through. So for each of these sets of chunks, we're going to say, so right now we can ignore the entity ID and we can just work on the position and the direction. So we can say chunks we need to get our span. What we need to do is we need to get our span from these chunks. So we need to say variable positions is component type position dot read write span. So we get a read write span for chunks component order component type dot flags dot position. That's it, yeah? Why is it complaining? Component order. Oh, we don't call it component order. We just call it comp order. So yeah, this is pretty straightforward. So we get a span of positions that we can write to by just plugging in the chunk that we got back from the query, saying we want to read write to it, plugging that chunk in and telling it which index of the chunk it is. And then similarly, we can get directions. So we'll actually get the directions first. We'll say directions. And directions is going to be read only. So it's going to be component type direction. Because we don't need to update the directions. We're just moving. It's going to be read only span. This is going to be chunks. There's a bit of indirection in this lookup, and we can probably improve that. Got a class, catch me later? No worries. Thanks for hanging out, Kolkas, and everyone else who came in with the raid. I hope people don't mind the lack of background music. We've been having some, for a number of issues, we've decided to kind of move away from that. And it's a little weird to me, just sitting in my own silence here, just with nothing but my own voice to listen to. Hopefully it's not too weird for other people as well. You feel me? Yeah. I'm having a hard time getting used to it, but I'll get used to it. It is nice. But it's good. You can still have me on while you play Delta Force. Hell yeah. Yeah, that's my hope too, is that way you can just do your own thing. I mean, I know it's harder if someone's on mobile, someone's watching on mobile or whatever, but like if you're on a computer, this is what I do. I mean, I just play my own music. Yeah, play a game, whatever. Hoping that's okay for everybody. Yeah, it probably bothers me more than anyone else because I can't. I could listen to my own music, but that's part of the problem. I got these new glasses, and they're like, if I put my headphones on, they just crush my skull. I get that. Oh, excuse me. I get that like glasses compression headache deal. I don't know why. I don't know why these glasses aren't good for that, and the last glasses I had didn't care. Maybe these are rounder or thicker or something, thicker frames. But it's weird. So yeah, I don't wear headphones when I stream now. It's kind of strange. All right, so we got our directions, we got our positions, and now we're just gonna say for each we need an item count. We need a count for this chunk. We need a chunk count. It doesn't really matter. We can just say for variable. Can I have a compound? Can this be for each? Can this be compound? Can this be like position in positions and direction in positions, direction in directions, and variable? No. Thought that'd be kind of cool. Then that's fine. We'll just say for variable for integer I equals 0, I is less than positions dot length. Well, that's not length. That's not right, is it? We need to actually know the chunk. So we need to say for I is less than chunks 0 dot item count. So we'll just do that. We'll just use the item count I plus plus. Yeah. You get it, symbol. Okay, so for each of these, we're just gonna say positions I plus equals directions I times delta time. Cannot apply operator pound to operands of type di.direction and system.nullable double. Oh, should probably convert this down to a float. Oh, maybe it's the nullable part. We could do a check at the top that's like, if delta time is null, throw something. Throw null reference exception. Throw new. Can I say this is like required? Oh, I probably need to add my own math here, don't I? Unless I just say this. Oh, you're a vector 3i. That's not right. That's not right. Directions, I get that why positions is a vector 3i, but I mean, I guess directions could be a vector 3i as well. So how do I do the math here then? Well, let's just forget about delta time then. So it's going to need to be positions I equals positions I plus directions I. So we need to assign it back. We can't just be like plus equals. So it needs to be dot positions dot value plus directions dot value. Y. We can totally convert Godot dot vector 3i back to target type di position. Maybe I messed up the something here. I thought I added a static implicit operator here. Yeah, we did. Why are you upset with this? The vector 3i. Direction should be the same. These operators should make this easy for me, or is this says explicit? Can we make this implicit? Maybe it's not supposed to be implicit, but can we do it? Would that solve the issue? It does, it solves the issue. Maybe that should be an explicit conversion. I know that's like the correct thing to do, but so I would just say position. I would just say new position value equals. How do I want to do this? There's so many ways. Can I just cast to a position? No. Oh, it's not that. It's this. I could just cast it like this. Just do an explicit cast. I kind of want to make this easier. Kind of want to make this better here. Make this a little less verbose, but maybe not. Maybe it doesn't matter. Just do it like this. Okay, well that should update our position by the direction. Nothing to do with delta time, but I get it. I get why. We're running in physics process, so, and we're running on whole ass integers, so maybe we don't care. But this is just a test for now. We might actually have like a way to convert from like a float position to like a rounded position or something like that. If we want, we probably want to have an accumulator style thing, or at least the effects of an accumulator. So position will probably become just an actual vector 3 instead of being a vector 3i, so that we can have, we can track subtle position changes. Like we can build up to a full grid position move. We have like grid position and like a raw position or something like that. Or maybe grid position is just rounded raw position. I don't know. We'll have to think about that because we're using a grid-based system, and like grid transactions is something we're going to want to handle eventually. Like transactions when you move from like one grid position to another, or you do something. Have something like that. But we'll see. This is good enough for now for at least testing purposes. And then what should we do? We should just like pick an entity, and we should just pick an entity and keep an eye on it. So let's turn this part off. So the right line we'll get drowned in debug right lines. Excuse me. So who is going to have a position and a direction when we're done with this? Components whose index matches 2. Okay, so we can just test. So let's just say debug. Well, we're not going to run this every frame, so let's put this on the move system. So let's just say when we're done with this, we're going to debug dot right line game dot world dot get component position. We need the entity ID. And that would be, how do we get that? I guess we just hack it right now. We just say entity ID 0, 1, 2, and index 2 version 0. Component type dot flags dot position. So we're just gonna keep an eye on this this entity here that should be having its position updated. We'll see if we need to write a toString. I don't know if I feel like debug log just does its own. Yeah, it writes the value of the object's toString method. And we should have a toString overwrite on here. We just need to add move system to the main system, so that the main system makes sure it's updating the move system. Oh, it's doing that already. Beautiful. So we get the test system ready. The test system is going to populate our world here. and then the move system will just handle the movement. It'll end up moving about a quarter of the entities based on the way that we've structured them. So here come the bugs. Yeah, all right, what do we got? Object reference not set to an instance of an object. Move system.run, main system. Move system.run for each chunk in move query. Oh, we're not setting the move system up in the ready. We need to definitely be doing that. Move system.ready. All right, now what's our issue? An item with the same key has already been added. Fascinating. Type flags, entity ID, position, direction, component count 3, largest component size 12. Try insert. Where is this happening? This is happening in create query. Huh. So we did this, we've done this already? So let's look at query by composition. So you only have this query. Oh, so we have a type flag, component count, and a largest component size. I love record structs. I love how record structs just print out the values of its members just automatically like this. Like we can see exactly what the key is. Whereas query is just useless. Query doesn't give me anything. It just says query. I'll need to override my own toString function to get anything useful out of this. So how in the world are we doing this twice? So in main system.ready, we call move system.ready. In move system.ready, we say move query equals gameworld.getQuery. And we say world.getQuery. Query by composition, try get value, composition out, very query, create query. So we are calling create query. And then we try to add this. But we got here because it didn't exist. Oh, I put this in the wrong order. No, yeah, this is right. So if query by composition, if we get a query out of this, then we should just return that query. Otherwise, we should create query. So we did not get a query out of this, right? This turned out to be null, false. Query is null. Query by composition is 1. NCB of all Gaia. Hey, how's it going? How are you doing today? Happy Saturday. All right, we only have one usage of this. It's going horrible? I'm sorry to hear that. That is unfortunate. I hope things turn around soon. So let's see, at this phase, do we already have this? Does this already have something in it? Queries by composition. This already has something in it. How? So we're on a get query. So this try get value thing, so we've already got something in here. Then we try to add it because we have to create this query because it seemingly doesn't exist. Okay, well this is a fun mystery. It should be relatively easy to figure out. So let's just find all of the references to this. Let's just go through them one by one. So dictionary composition query. So we create this here. Down here, We add this. This is where it failed. I tried to add this. Down here, we have a reference to it around here somewhere. Oh, wait, what is this? Method get archetype can be made oh, that's just a... No, that's not true. Oh, maybe it's true. All right, so get archetype by composition. It's also referenced down here. So get query, query composition, try get value, register query, query by composition. Oh, when we register query, we just add it. You just add this composition to this query. Okay, so we already register this thing, or we already have this thing when we register it. Where are we registering a query? We should do it when we create it, right? Yeah, so we create this query, we register it, and then when we call ready, system.ready, we say move query. Game world, we say game world.get query. So somehow this doesn't just return the query, it attempts to create the query again. So we're making a new composition here. So we make this composition. We create this query. We say game world.get query. So where's this register query thing happening? Who calls this? Who is using this? Game world.register query. Public query. Okay, so when we create a query, we register a query. Here's maybe the problem. So when we create the query, we're registering it. And then when we try to get it, maybe there's some kind of race condition here. I don't know. So when we construct the query, we do this. Maybe this is not best to have here, but this is kind of what we're doing. And then in the move system on ready, we try to get this query. Maybe our problem here is this private query move query thing. Well, I don't understand. Who calls this? You call this. Public class query. Who is making queries? The world is creating a new query here somewhere. Where are you doing this? Oh, you're doing this in create query. This is the correct way to do this, I feel like. Oh, maybe. Oh, we need to remove this from this. The call to new query is registering the query, and then we're trying to add the query to that dictionary twice, even though it's being added in this new query call. Figured it out. I'm an idiot. I tried to do something twice. So we're doing this here. We're doing this in the constructor. So we do a register there. Okay, that's that bug. It worked. No compiler errors. Let's go look at the debugger. Oh, look at this. Look at this. We're updating positions. We're doing it like really fast, but it's working. We're iterating over all the positions and incrementing them. That's super awesome. I was not expecting this to work, honestly. But it's working. Okay. We got queries. That was way easier than it should have been. It was like that was like 2 days just to do the queries. That should have taken longer. Admittedly, we need some like we need some more complicated queries than this. We need to be able to specify knots. We need to be able to like, do you have this component but not this component, you know? So there's definitely some additional functionality we need, but do we need to do it right now? Is my question. Is that a right now thing? Or do we just take the W and just are happy with this and maybe think about getting back to like gameplay programming? A knot would be really easy because we already have an archetype like contains. We could have an archetype dot uh, like excludes. Maybe we have includes and excludes instead of contains. I like contains. I think contains is cool. It kind of suggests an almost physical aspect to it though, like in terms of size. And I don't know what the opposite of contains is, except maybe excludes. Antonyms for contains. Yeah, it's excludes or omits. But if we're doing exclude, I almost want to do include and exclude. Oh, disclude is a word. That's fun. I love those words we don't use that sound like regular words we use all the time, like apposite with an A. Nobody says that, but it's like a perfectly valid word. All right, move system functions. I'm so happy. Do we have like what does our test system use? We use a print component values. Let's do this. Let's just test this real quick. So we have this print component values. So this gets substituted in with this. Why do we need to call get archetype? Oh, because we need to get the archetype. Then we need to print the component values and pass in the entity again. That makes sense. We're gonna do this. We're gonna do this debug. We're gonna do this a different debug.writeLine. But I kind of want to simplify this a little bit. We're gonna do a slightly different test just for shits and giggles here, just to make sure the all the component data is flowing correctly. Yeah, here we go. So we're getting the entity. We're asking for the data of entity ID 2. We're getting back entity ID 2 with this position that's incrementing based on this direction. So direction value 2, 3, 4 is being added to their position every frame. That's awesome. It's really small and simple, but it's awesome that it works. Because what we're not saying, but we're also doing, is we're actually making, our test system is actually making and then manipulating 4,000 entities. And we're just picking one at random to like check. but like at least 1,000 of these are having their positions changed. And we're doing it across chunks. Probably. Maybe not. Let's increase the size of this test. So what's the next size up from 4096? It's 80. Let's have a const test count. Integer. That's 8,192. That's the next number. That's the next power of 2 after 4096. Substitute in test count here. All right, I just want to make sure we're testing across chunk boundaries. That's like the most important thing for me that we're testing. Because each of these chunks can hold about 1,000 plus entities. And so my only concern is that the chunk that or the archetype that contains position and direction is able to do this with with like only one chunk. I want to make sure that we're testing for multiple chunks here. So we'll run this test again real quick. Well, seems to be working. Oops. Cool. Let's add a breakpoint and just check the game state when we were doing this. Add a breakpoint on the debugger, run that. I just want to be super confident that this system works because I don't want to deal with this once we know that it works. I want to look at the world. So our live entities count is 8193, which is not great. I feel like we're going over in that case. Is that true? Okay, so 8190 should be 8192. What have I done wrong? The test system. Test count is 8192. For its 0. Oh, it needs to be less than 1. Because we're using it as a... Well, no, that's not right. That should be fine. I is less than test count. I is 0. I is less than test count. 80. There should only be 8191 here. Or there should be 8192 because we have a test count of 8192. And we're saying I equals 0. I is less than test count. I plus plus. How are we ending up with 8193 entities? Perplexing a little bit. Let's dig into this a little here. So live, oh, this is the live entities count. Ah. And entity IDs is 8193. Well, hold on. That doesn't make a ton of sense either. Whatever. This is just a test system. Who cares? I'm bungling up the count a little bit. Archetype by entity ID only has 8192. So why does the entity ID list have 8193? A little weird. Why are all the versions 0? We should be incrementing some version numbers. I guess we actually won't do it until we get way past this. This collection view is kind of slow. Maybe one problem. Which, like, I get it, I guess. We're just looking out to see when the version number increments here. It should happen around 4,000. I don't know. I don't know if I care about this. I've already verified that this works. I'm just kind of curious. Kind of curious what's happening. I mean, by this logic, there's going to be an 8192. There's going to be an entity with an index of 8192, and I guess I should just check to see if that's the case. It should crash. Oh, it didn't crash. Oh, because we turned off the debugger. I hit the wrong button. Oh no, we crashed. Yeah. Okay, so there isn't an 8193rd entity. Step over this. Yeah, crash. Okay. So we're not creating a third one. We're just there's maybe something weird happening with the list. Oh, it's probably because we're adding something and then removing it. I don't know, who cares? I should care more about this specific thing, but I don't totally want to investigate this at the moment. It's kind of hard to investigate. But it's working. The query system's totally working. It's beautiful. It's a beautiful thing. It's a little weird why live entity count is 8193. But archetype by entity ID is 8192. Okay, 8191 here is occupied by key 1. That makes sense. That should be the last one. I think I'm just getting tricked up by like a capacity thing. I think it's fine. All right. I'm really happy with today's progress. Really happy that we gotten queries sorted out. Been live for a few hours here. I'm kind of hungry for lunch, so I think we might raid out. Thanks again, Practical MPC. For the raid here. Really appreciate that. Hope everyone's doing great. I think we might raid out to Irish John. They're doing some side project Saturday stuff. But I hope everyone's enjoyed it so far. With this query system done, we're going to get back to gameplay programming next week. That's exciting. We have not been doing gameplay programming stuff in like a month or two because we've been working on this entity component system. But I think it's done. I think it's ostensibly done now. So we can get back to more interesting stuff. So yeah, I want to say thank you all so much for watching. I hope you have a great rest of your weekend, and I'm going to see you next time. Bye.